Set up a snapshot rerun application. I will cover more target objective focus details on debugger during the objective coverage. Operations trace gather and analyze trace flows to understand performance issues such as latency and bottleneck discovery. Operations trace can also analyze apps and generate reports. Test tip: Trace SDK supports Java, Node.js, Ruby, and Go. Figure 4.10 shows the Stackdriver trace heatmap, the fee image. Stackdriver profiler operation, the fee image. The fee image. Stackdriver profiler operations profiler allows developers to analyze applications running on GCP and other cloud platforms, or on-premises. Test tip: the main use case for continuous CPU and heap profiling is to improve performance and reduce costs around your application. Operations profiler continuously analyzes the performance of CPU and memory-intensive functions executed across an application. Operations profiler presents the call hierarchy and resource consumption of the relevant function in an interactive flame graph. Operations is a very powerful and complex suite of solutions from Google. The learning curve for Stackdriver is more than just a few hours, so I encourage you to further your learning in this area. Table 4.2 Operations Suite, Stackdriver, Use Cases. Operations Suite Capability Summary of Use Case. Operations Suite allows you to monitor, troubleshoot, and improve application performance in your Google Cloud environment. Monitoring: use a native monitoring solution for Google Cloud environment insights or extend to a hybrid solution with OARS. Logging: maintain audit compliance and historical activity. Error reporting: analyzes and aggregates the errors in your cloud applications. Trace: gather and analyze trace flows in near real time to identify bottlenecks. Debug: inject logging into a real-time service without stopping it. Call service. Profiler: understand CPU and heap profiling to improve performance and reduce costs. The Devops exam will test you heavily in this area, so prepare accordingly. I encourage you to take the free Developer Focus Labs on Labs to get a firm idea of how to use Stackdriver. If you're not familiar with Stackdriver, then you're likely not going to pass this exam. https://codalabs.developers.google.com/link. Figure 4.11 shows the Codalabs for operations available for free. Figure 4.11 Codalabs Terra image. Exam objectives: note icon image. Let's review what we learned. Topic: Stackdriver operations. This topic focuses on reviewing the main areas of cloud operations for the exam. The main objectives to be summarized and reviewed: cloud operations. A summary of chapter operations. Stackdriver is a hybrid service that helps your enterprise with monitoring, logging, error reporting, tracing, profiling and debugging your services and your applications on Google Cloud. You can use operations when an application becomes more complex in terms of number of services, number of applications, or scale of deployments. Stackdriver has customizable dashboards you can create where you can compare different usages of different projects in a centralized environment. Creating new metrics is also flexible and easy to use. With Stackdriver logging, you can read and write log entries, search and filter your logs, export your logs, and create logs-based metrics. The service pulls performance metrics and metadata from multiple cloud accounts and allows users to view virtual and graphical representations of that data through custom dashboards, charts, and reports, which makes it easy for users to monitor, debug and fix issues. In a nutshell, Operations Suite allows you to monitor, troubleshoot, and improve application performance in your Google Cloud environment. Terminology to know. Exam objectives: note icon image. Let's discuss Stackdriver terminology. Topic: Stackdriver operations terminology. This topic focuses on what Stackdriver operations is all about and to cover specific areas for the exam. The main objectives you will learn about is Stackdriver terminology for exam preparation. Operations, Stackdriver, terminology to know for the exam. The exam will test your knowledge around a limited focus of operations terminology. The list below summarizes terms briefly that commonly would likely be tested on the exam. Aggregated sinks allow exporting log entries from multiple resources. Dashboard is a console view that allows you to group specific resources. To view and monitor log router is a new feature that makes exporting logs easier. Log sinks are used to export logs to a destination. Sinks can be a single resource or aggregated. Operations, Stackdriver, practice questions before you begin. The main objective of these practice questions is to validate that you have learned the objectives of this chapter. Answers with explanations are on the following pages. 1. Operations logging supports a default log retention of how many days? Select 1, 3100, 30, 1000, 3400, 400, 10,000. 2. Metrics in operations monitoring metrics be retained. Select 1, 24 months, 12 months, 30 months, 16 months. 3. Logging exports can be to every cloud service except. Select 1. Bigtable, BigQuery, Cloud Storage, Cloud Pub Sub. 4. When you make a change to an uptime check delay, the delay could be up to how long? Select 1. 10 minutes, 10 seconds, 25 minutes, 60 minutes. 5. Your customer has asked to notify them of specific login activity. You just created a log sync for this. What would be your option for log syncs to send data to? Select 1. Bigtable, BigQuery and Cloud Storage, Cloud Pub Sub, BigQuery and Cloud Storage, Cloud Storage, Cloud SQL and Cloud Storage, BigQuery, Cloud Storage and Cloud Data Store. 6. Your customer has asked that all errors be sent to them. How would you do this? Select 1. Use operations logging and set up triggers to alert for events. Use operations error reporting and set up triggers to alert for events. Use operations logging and set up syncs to alert for events. Use operations monitoring and set up triggers to alert for events. 7. What operations capability can display data in near real time and perform latency samples? Select 1. Trace error reporting debug. Profiler 8. You have a containerized application on Gke and would like to ensure your team has visibility into the application metrics and alerts. What should you do to ensure this can occur? Select 2. Set up a dashboard for the Gke clusters that will be viewed by the team. Set up a dashboard for compute engine instances. Set up alerts on the monitoring dashboard that need to be viewed. Set up a log sync and send logs to Cloud Pub Sub. 9. You're currently using Debugger for an application and would like to show your team members how it can work. What are the 2 statements about Debugger that are true on how it works? Select 2. Debugger automatically selects the source code, snapshot or application. Debugger captures the call stack and local variables of running application. Debugger injects logging into a service without stopping it. Debugger continuously analyzes the performance of CPU or memory. Intensive functions executed across an application tend to create or modify a sink. You must have the or in the sink's parent resource. Select 2. IAM roles owner logging logs configuration writer project owner logging logs configuration viewer answers to section practice questions. The following are the answers to the questions. You may want to go back to the text and confirm you understand the answer before taking the exam. The exam questions are similar in format and difficulty. 1. C 3402. A 24 months 3. A. Bigtable 4. C 25 minutes 5. B. Cloud Pub Sub, BigQuery and Cloud Storage 6. A. Use Stackdriver logging and set up triggers to alert for events. 7. A. Trace 8. In C. Set up a dashboard for the Gke clusters that will be viewed by the team and set up alerts in the monitoring dashboard that need to be viewed. 9. B. C. Debugger captures the call stack and local variables of running application. Debugger injects logging into a service without stopping it. 10. A. B. IAM roles owner, logging logs configuration writer. Chapter 5. Exam objectives coverage. In this chapter, the coverage is specifically geared towards the exam objectives. The exam objectives are referred to as the skill set on the Google Cloud DevOps Engineer exam website. Each objective is covered in detail in this chapter as well as a practice exam at the end of the chapter. Test tips are provided in each section. Chapter overview. In this chapter you will learn exam objectives summary, practice questions and answers, Exam objectives coverage. Exam objectives note icon image. Let's discuss the exam objectives topic. Exam objectives coverage. In this topic, we cover the exam objectives in order with concise detail. The main objectives you will learn about are focused on each main objective area listed by the vendor. Each objective area is then broken into sub-objectives that are clearly defined on the vendor website. Exam objectives. Applying site reliability engineering principles to a service. Exam objectives. Building and implementing CI/CD pipelines for a service. Exam objectives. Implementing service monitoring strategies. Exam objectives. Optimizing service performance. Exam objectives. Manage incidents. Section 1. Exam Guide. Applying site reliability engineering principles to a service. Exam objectives note icon image. Let's discuss the exam objectives topic. Exam objective coverage for SRE related in Section 1 of the exam guide. In this topic, we cover the exam objectives in order with concise detail. Exam objectives. Applying site reliability engineering principles to a service. Objectives. Section 1. Applying site reliability engineering principles to a service. This section is focused 100 reliability engineering best practices and trivia. Note that this section is totally reliant on Google's view of the world, and this means reading the SRE workbook will be important. There is nothing technically difficult, and effectively the section is more administrative around collaboration and SRE. It is important to go into the exam appreciating that site reliability engineering, SRE, represents a significant change from existing industry best practices for managing services. Below, I have summarized the objectives as efficiently as I could. It's really important that you do scan the SRE that is free online, since that's where most of the objectives appear to come from. 1.1 Ball velocity and reliability of the service. Objectives of 1.1 in the areas of coverage are: discover SLEs. This objective is focused on service level indicators, SLEs, which are used to obtain the service availability percentage through a direct measurement of SLO conformance. When discovering SLEs, we should be aware that these are commonly collected on the server side, using a monitoring system such as Prometheus, or even through syslog discovery such as error code 402. Define SLOs and understand SLAs. The definitions are as follows. Service level objective, SLO, is a specific measurement that provides a numerical target that must be reached for system availability. SLOs should specify both the target and a measurement window. For example, the 99.999% availability or less than 100 milliseconds latency response test time will be tested on SLO versus SLE versus SLA. Service level agreements, SLA, are a looser number than the service level objective, SLO. Think of the SLO as the internal number the service provider uses to measure themselves, while the SLA is the number that the customer uses for a guarantee is usually specified as a percentage such as 49s or 99.99%. Availability uptime response. Agree to the consequences of not meeting the error budget. The error budget is based on the service's sective or service level objectives, SLO. The error budget provides a clear, objective metric that determines how unreliable the service is allowed within a time frame such as month, quarter. For example, if there is an error budget remaining in the month's results, then the team can proceed around updating the application. If the budget, let's say around uptime, has been met, then the application updates would not be allowed due to a collaborative agreement. This would be a consequence. It is important for success that politics are removed from negotiations between SREs and the product developers when deciding how much risk to allow. Construct feedback loops to next. Feedback is very important to receive and provide as an SRE. Feedback can be human or even tasking, such as metrics like latency, error rate, rework rate, and human time saved. Test tip. SRE considers acceptable risk and error budget. When error budgets are depleted, the focus to improving reliability. Post-mortem and post-incident reviews are needed to review problems in production and effectively learn more about how your system will upon weaknesses. Toil automation. Toil is work that an SRE team member needs to deal with manually. There are other characteristics for toil such as repetitive, reactive, or lacking enduring value. Reducing toil is done through automation. Toil is impossible to eliminate, but through a toil budget it can be managed. For example, Google expects that a toil budget would only expect 50% of each site reliability engineer's time goes to coding. The other 50% daily care of existing applications. Toil can be measured through the following approaches. Identify what toil is for your organization. Select improve. Test tip: ownership of incidents and responsibilities is important, and blame should never be acceptable. Reduce technical debt. Technical debt is effectively work that has not been either resolved or automated. The best way to reduce technical debt is to fix it. No excuses or blame should be acceptable in the organization. Automation will reduce toil. Toil can be reduced by automation but will never totally remove the toil. Toil should never be more than 50% of an SRE's time. Objectives 1.2 and the areas of coverage are focus, services and deployment management. The product or service lifecycle is a process that follows the different stages that a product or service encounters. The life cycle is broken down into 4 stages that help to identify where in the market the product or service is at the current time. In Google View, an SRE team's contributions to service reliability happens throughout all phases of the service lifecycle. When managing a service, it is important to realize that SRE is a different take on the world of service management. Site reliability engineering, SRE, is Google's approach to service management. Google SREs started a systematic approach called the Simple Production Readiness Review, which made strides in standardizing the SRE engagement model, which is applicable to services that have already entered the launch phase. Test tip: early engagement model, which involved SRE earlier in the development lifecycle in order to design for reliability. Google then ensured that these frameworks became a recommended, consistent, and relatively simple way of building production-ready services for your enterprise. Plan for capacity. Planning for capacity combines both change management and capacity planning. Provisioning must be conducted efficiently since capacity is considered expensive. Ensure your organization has the proper tools to maintain capacity and also ensure your team is able to comprehend demand versus capacity. Test tip: forecasting should be performed short-term in an active manner but also more strategically in a planned manner. With forecasting, SRE teams should be working with development to produce long-term plans as well. Collaboration is a key factor around ensuring capacity is always available. 1.3 Ensure healthy communication and collaboration for operations. Prevent burnout. Burnout is a result of working a job that has become physically and/or emotionally tiring. Especially after long periods, Google realizes that burnout should be recognized and addressed. An SRE is subjected to immense stress when there is an outage, and this can continue after the incident has been closed. Preventing burnout is very important, and to do this we must recognize that this is a problem with the team. Test tip: consider soft solutions such as regular time off, mandated vacations and better collaboration to reduce burnout. Some ways to minimize burnout are to follow best practices, have clear metrics and objectives in your SLO, SLI and SLAs, but also to ensure proper communication through appropriate channels are just some of the things to consider. Foster a learning culture. A solid learning culture should be promoting failure as a learning opportunity. Another important facet of a solid learning culture is to ensure blamelessness is implemented. The culture should promote continuous learning as well by ensuring the SRE team has proper learning opportunities. Post-mortems should be used as part of the work culture as a learning opportunity. Foster a culture of blamelessness. Blame should never be acceptable, and to foster this culture your enterprise should consider the following 3 best practices. First, organizations should foster a blameless culture and ensure that incidents are also learning events. Failure is very normal and needs to be accepted. 100% uptime is not going to happen on most enterprise services. Accept failure as normal. Second, holding a blameless post-mortem is an SRE best practice since incidents are used as learning opportunities. Thirdly, having an error budget for SLOs as a cushion for failure is expected. Section 2, Exam Guide. Building and implementing CI/CD pipelines for a service. Exam objectives. Note icon image. Let's discuss the exam objectives. Topic: Exam objective coverage for SRE-related objectives in Section 1 of the Exam Guide. In this topic, we cover the exam objectives in order with concise detail. Exam objectives: building and implementing CI/CD pipelines for a service. 2.1 Design CI/CD pipelines. This section is mainly focused on cloud build, container registry, cloud source repositories CSR, Gke, and third-party tools. Immutable artifacts with container registry. When building and deploying containerized applications, use immutable artifacts as units for deployment. This approach makes things much simpler to deploy resources. Immutable artifacts ensure that you can deploy and scale your software across many hosts and environments, knowing that it will behave as you expect. Container registry is a way to store artifacts on Google Cloud as well as cloud storage. Container registry artifacts could be container images, binaries, or other code files. Artifact stores hold artifacts in the container registry. Artifact repositories with container registry. The artifact registry is really the way to now manage artifacts. You can still use the container registry as well. Artifact registry is a fully managed service with support for both container images and non-container artifacts. Test tip: before pushing containers, you need to authenticate Cloud as a credential. Helping Cloud Auth configure Docker Artifact Registry is where you can manage your container images and language packages. Some notable features. Registry-specific permissions. Artifact Registry offers more fine-grained permissions, allowing you to control access at the project or registry level. Regional support. Create multiple regional repositories within a single Google Cloud project. Multiple repositories with separate permissions. You can create multiple repos under a project with independent artifact registry-specific permissions. You have control over where artifacts are stored and who can access them. Use the following command to create a new artifact repository. Cloud Beta Artifacts Repositories. Create repository deployment strategies with Cloud Build and Spinnaker. An automated process that reliably builds, tests, and updates your software is most effective. Code changes should automatically flow through a pipeline that includes artifact creation, unit testing, functional testing, and production rollout. You may want a code update to apply only to a subset of your users, so that it is exercised realistically before you push it to your entire user base. Deployment of hybrid and multi-cloud environments with Anthos, Spinnaker, Kubernetes with Google Cloud. Your organization has options such as Anthos, especially with a hybrid deployment. You don't have to decide between Google Cloud Platform, GCP, with Google Kubernetes Engine, GKE, or GKE on-premises. Anthos is a modern application management platform that provides consistent development and operations experience for cloud and on-prem environments. Test tip: you can combine the two into a hybrid cloud managed by Anthos to gain the best characteristics of both GKE and GKE on-premises. The primary computing environment for Anthos relies on Google Kubernetes Engine, GKE, and GKE on-prem to manage Kubernetes installations in the environments where you intend to deploy your applications. Combining the two into a hybrid system means you can keep all your sensitive data and applications operating within your data center and use the elastic scalability of the public cloud for everything else. Artifact versioning strategy with Cloud Build and Container Registry. Artifact Registry is really the way to now manage your developer artifacts. You can still use the Container Registry at the time of writing. Artifact Registry is a fully managed service with support for both container images and non-container artifacts. CI/CD pipeline triggers with Cloud Source Repositories, Cloud Build GitHub app, Cloud Pub Sub. Having a CI/CD pipeline trigger setup is relatively simple. For example, when a new commit occurs to your Cloud Source Repository, a trigger should be set up Cloud Build to build a Docker image based on the source repository. This repository could be GitHub as well. Cloud Build is now pushing the image to the container repository and will publish a message to Cloud Pub Sub. Testing a new version with Spinnaker. Spinnaker is an open-source, multi-cloud continuous delivery platform that helps you release software changes with high velocity and confidence. Spinnaker is composed of a number of independent microservices and thus can time some planning to deploy. Configure deployment processes. Deployment automation is what enables you to deploy your software to testing and production environments with no manual intervention. Automation is essential to reduce the risk of production deployments. Test tip: it is recommended that you use the same deployment process for every environment, including production. It would be advisable to use the same packages for every environment. Deployments should be repeatable, so you should be able to recreate the state of any environment from information stored in version control. Cloud Deployment Manager can support in this mission as with other tools such as Spinnaker or Terraform. 2.2 Implement CI/CD pipelines. CI/CD with Cloud Build. CI/CD with Cloud Build begins by creating a file called Cloud Pool YAML at the root of the project. Example, YAML in the appendix. Figure 5.1 shows the build summary in the Cloud Build console dashboard. Figure 5.1 Cloud Build image. You can also use the console as well to create a build, create a trigger and view logs. Figure 5.2 shows a build trigger can be created. Figure 5.2 Cloud Build trigger image. This YAML will tell Cloud Build the steps required to build and test your code. Effectively, the build takes place in 4 steps: install npm dependencies, run unit tests, run production, build, deploy your builds. It is also important to note that the builds, before they will work, will need appropriate service account permissions. Figure 5.3 shows the settings for service account permissions. Figure 5.3 Cloud Build Settings. Image. Open source tooling. The exam will test you on the basics of some of the common open source tools. Not at a deep level, but more of at a functional level. Below are the ones for these objectives. Jenkins is an open source automation server written in Java. It is used to continuously build and test software projects, enabling developers to set up a CI/CD environment. It also supports version control tools like Subversion, Git, Mercurial, and Maven. Spinnaker is an open source, multi-cloud continuous delivery tool that helps you be intentional about how you ship software by granting visibility and control into your software delivery process. GitLab is a service that provides remote access to Git repository. Git also provides features designed to help manage the software development lifecycle. Concourse is an open source automation system written in Go. It is most commonly used for CI/CD and is built to scale to any kind of automation pipeline, from simple to complex audit and tracing of deployments. Kubernetes has several ways to audit and trace deployments. For example, a status value other than running indicates an issue with the Kubernetes infrastructure. An on0 and growing value in the restarts column indicates an issue with that Kubernetes pod. Kubernetes engine keeps a chronological record of calls that have been made to the Kubernetes API server. Test tip: learn how to view the audit log streams, which are admin accounts and data access. Maintaining these Kubernetes audit log entries, project level, is useful for investigating suspicious API requests, for collecting statistics, or for creating monitoring alerts for unwanted API calls. Cloud Audit Logs is a service that consists of 2 log streams. Cloud projects have 2 logs, which are the admin activity log and data access log. Admin activity login is enabled by default and has no extra cost. Data access logging is disabled by default, and enabling these logs can result in extra billing. These streams help you answer the question of who did what, where, and when within your GCP projects. To enable logs, you need to run the command to view and then edit the policy. Cloud projects get IAM policy project ID K8 policy YAML view log files in Log Viewer. Figure 5.4 shows the logs for the Gke cluster. Figure 5.4 Gke Cluster Logs. Kubernetes engine clusters have 2 services that will log entries that you can filter. They are K8SIO, Kubernetes, and container googleepus.com, Kubernetes engine. Logs page in the logging menu. Below is an example of a Gke cluster logging event image. You can also view the logs in cloud by using the cloud logging read command. 2.3 Manage configuration and secrets. This specific objective is focused on secure deployment and management of your container builds. Secure storage methods. These are clearly documented storing secret best practices. They are listed in the recommended order. 1. Storing secrets in code that are encrypted with a key from Cloud KMS. 2. Storing secrets in a storage bucket in cloud storage, which is encrypted at rest. 3. Using a third-party secret management solution. Test tip: storing your secrets directly in code is not a best practice for GCP. In GCP, you have 2 options for encrypting secrets, either by using an application layer encryption by using a key in Cloud KMS. This is the recommended option. Another option is to use the default encryption built into the cloud storage bucket. GCP encrypts customer content stored at rest, using 1 or more encryption mechanisms managing access to secrets. There are 2 main options to restrict and enforce access to GCP access controls on the bucket in which the secret is stored. This option can support multiple secrets objects per bucket, or only a single secret per bucket. This is the recommended option. Access controls on the key which encrypts the bucket in which the secret is stored. This option supports multiple secrets per key, or only a single secret per key. Deployment Manager. We may want to use either metadata or a secret container secret rotation and config changes. Secrets are often rotated when a new version is created. Secret rotation results in a secret having multiple versions. Manage as needed, but never store your secrets in your code. When it comes to rotating and storing secrets, we need to ensure that we do not provide storage of secret keys in the application directly. Using Cloud Deployment Manager, Secret Manager, metadata or a secret container volume is best practice. Utilities such as Cloud KMS, Cloud HSM and HashiCorp Vaults are good options to employ secrets. Below are some common changing secrets best practices. Rotating secrets. Use multiple versions. Cache secrets locally several times per hour. Using a separate solution or platform GCP, you have two options for encrypting secrets, which are test tip. Use application layer encryption using a key in Cloud KMS. This is the recommended option. Use the default encryption built into the cloud storage bucket. GCP encrypts customer content stored at rest. Using one or more encryption mechanisms, Secret Manager is a newer, secure and convenient storage system for API keys, passwords, certificates, and other sensitive data. Secret Manager provides a central place and single source of truth to manage, access, and audit secrets across Google Cloud. In Secret Manager, a secret is a wrapper around a collection of secret versions. The secret stores metadata such as labels and replication, but it does not contain the actual secret. Test tip: update to secret's metadata. You need the roles Secret Manager admin IAM role on the secret or the parent project as Secret Manager. We should be aware that a secret version can be in one of the following states at any given time: enabled, disabled, or destroyed. 2.4 Manage infrastructure as code. Infrastructure as code, IAC, allows your organization to use continuous integration and continuous deployment techniques. This reduces the manual errors after the development stage. Infrastructure such as code is a prerequisite for common DevOps practices such as version control, code review, continuous integration and automated testing. These practices provide continuous delivery of quality software that meets the requirements set. DevOps and solid infrastructure best practices are a must-have for leading software development organizations. Google Cloud has a hosted solution called Cloud Deployment Manager, or you can also use your on-premises solution such as Terraform. Google Cloud Deployment Manager allows you to specify all the resources needed for your application in a declarative format using YAML. You can also use Python or Jinja 2 templates to parameterize the configuration and allow reuse of common deployment paradigms such as a load-balanced, auto-scaled instance group. Table 5.1 compares OR's CloudFormation basics to GCP Cloud Deployment Manager. Table 5.1 Gke Cluster Logs image. Treat your configuration as code and perform repeatable deployments. Terraform Cloud Deployment Manager. Terraform is a team-oriented IAE solution that is meant for changing and versioning your infrastructure securely. It has support for code repositories, peer review and final source control. Test tip: use Terraform to manage code with the team. Cloud Deployment Manager allows you to specify all the resources needed for your application in a declarative format using YAML. You can also use Python or Jinja 2 templates to parameterize the configuration and allow reuse of common deployment paradigms such as a load-balanced, auto-scaled instance group. Basically, treat your configuration as code and perform repeatable deployments on Google Cloud. Infrastructure code versioning. The version control system records changes to files stored in the system. These files can be source code, assets, or other documents that might be part of a software development project. Dev teams can make changes in groups called commits or revisions. Ensures that you have consistency, reproducibility in your deployments and that you have record, traceability of your code-based changes. Test tip: version control helps your organization meet the critical requirements around reproducibility and traceability. Versioning allows you to also rebuild it in a short amount of time without too much trouble. Other benefits revolve around the ability to test, but also you can also rapidly promote updates from dev to staging to production efficiently. Terraform is a great example of a solid tool that is used for this purpose. You may also want to review the version control page that Google has provided: https://cloud.google.com/solutions/devops/devops-tech-version-control. Making infrastructure changes safer. Sometimes things just do not go according to plan, and therefore we need to make changes to the build or the deployment. For example, the Cloud Deployment Manager has a preview flag you can use to preview changes before running the deployment. Terraform, for example, will review the plan for incorrect changes and you will safely abort with no changes made to your infrastructure. You have the choice whether or not with Terraform apply Immutable Architecture. Immutable infrastructure is effectively an infrastructure that is created once and does not change. This is a different way of thinking where updates changes are commonly deployed on top of builds, OS, and applications. Immutability can be achieved, for example, By deploying your CI/CD pipelines to produce a completed image with the newer version of the application code config already deployed effectively. The image is ready to work when provisioned on a VM, for example. Spinnaker is a commonly used comprehensive end-to-end build and deploy solution that provides for an immutable infrastructure 2.5 deploy CI/CD tooling. This specific objective is focused on how tools can be used to provide for collaboration and security. Centralized tools versus multiple tools, single versus multi-tenant. When considering centralized tools or multiple tools in an organization, it really comes down to how mature the organization is from a software development perspective. Centralized tools can be very effective when you're investing in CI/CD. For multiple teams inside the same organization that will collaborate as effectively as a single team, this can also facilitate corporate standards around development as well much more effectively. Multiple tools may be needed when the organization has departments that have very different lines of business and likely will not collaborate well together for any number or reason. Security of CI/CD tooling. Security around the build steps is needed to create a secure pipeline. But also, during the deployment phase, keeping track of what code that is sent to production is important, and the versioning and scanning of the code to ensure it has not been tampered with is critical. Automation of your DevOps foundation will help keep the enterprise up in an agile environment. Environmental isolation and separation from production is also very critical to implement. This can be done in GCP through the implementation of cloud projects and proper IAM controls. 2.6 Manage different development environments. This section is mainly focused on how to handle development, QA and test environment with the proper GCP tools. Decide on the number of environments and their purpose. There are a number of factors that can go into deciding what development environments we would need for our cloud deployment. The easiest way to break this down is by creating separate projects in GCP. The project will facilitate the organization of services and objects. This is an effective means for segmentation of resources, billing and IAM as well. For example, we could create a project for development and then create another for staging and production. When deciding on the number of environments, it can depend on the workflows created, the lines of business resource allocation, layers of development required, and even levels of testing needed. Some examples of environments and their purpose are the development environment. Dev is for building and testing the code before it gets to the next stage. QA testing environment is for testing professionals to perform many forms of functional and non-functional testing, such as end-to-end testing, load testing, integration testing, and more. On the mainline copy, staging environment is a copy of the production environment and is meant to provide assurance before deployment in production. Production environment is where the software is placed in operation and is used by the user base. Create environments dynamically per feature branch with a Gke Cloud Deployment Manager. Generally, a feature is your own personal branch where you modify the code. You can dynamically set up a triggering cloud build which will automatically start to build when you make a change to your code. There are different types of triggers as well. Figure 5.5 shows the cloud build trigger creation page. Figure 5.5 triggers. Image. There is also the build triggers API which can be configured for an automated build in response to source repository changes for more than one project. Local development environment with Docker. Cloud code. Scaffold. Docker is a tool designed to make it easier to create, deploy, and run applications using containers. Docker Compose is a tool for defining and running multi-container Docker applications. Compose and use a YAML file to configure your application's services. Cloud Code is a tool created by Google to allow you to write, debug, and run your cloud-native applications. It effectively is a new set of plugins for intelligent VS Code that brings automation and assistance to every phase of the software development lifecycle. Cloud Code has a full Kubernetes development environment and integration with Cloud Run for Anthos. Test tip. Cloud Code has two plugins. Intelligent VS Code Scaffold was created by Google, which is a CLI that facilitates continuous development for Kubernetes applications. You can iterate on your application source code locally and then deploy it to local or remote Kubernetes clusters. Scaffold handles the workflow for building, pushing and deploying your application. It also provides building blocks and describes customizations for a CI/CD pipeline. It is a client-side tool that interfaces with your RIDE 2.7 secure the deployment pipeline. This specific objective is focused on ensuring your production copies are deployed in a secure manner. It covers features such as container registry, binary authorization and its terms, as well as how to deploy a container vulnerability analysis with Container Registry. Google Container Registry provides secure, private Docker image storage on GCP. Container Analysis is a service that provides vulnerability scanning and metadata storage for software artifacts. The scanning service performs vulnerability scans on images in Container Registry, then stores the resulting metadata and makes it available for consumption through an API. The Container Analysis API needs to be enabled, and then cloud-built images are pushed to the Container Registry, which then automatically scans the containers. Feedback on threats and issues is then given to the user. Test tip: Container Analysis associates metadata to images through notes and occurrences. Notes are metadata in Container Analysis storage that is associated with an attested test tip. You can view image vulnerabilities and image metadata for containers in Container Registry using Cloud Console, Container Analysis API, gRPC and REST-JSON, and Cloud Command. Cloud Beta Container Image List Tags. Show occurrences. Binary authorization. Binary authorization is a service that allows only attested images to be deployed to the cluster. An attested image is one that has been verified or guaranteed by an attester. Any unauthorized images that do not match the binary authorization policy are rejected, as shown in the figure below. Test tip: the default binary authorization policy allows for all images. Before we continue, there are some terms to understand. Container Analysis is an API that is used to store trusted metadata about our software artifacts and is used during the binary authorization process. The person or process attester attests to the authenticity of the image. Note: this is a piece of metadata in Container Analysis storage that is associated with an attester. The statement from the attester states that an image is ready to be deployed. In our case, we will use an attestation that refers to the signing of our image. Test tip: A denied by attester. Errors will be returned if no attestations are found that were valid and signed by a key trusted by the attester. To set up binary authorization, there are some tasks that need to be completed for the project hosting the Kubernetes cluster. Enable the required APIs. Create a Kubernetes cluster that has binary authorization enabled. Set up a note. Generate PGP keys. Create an attester. Figure 5.6 shows how binary authorization can be enabled in the Gke console creation process. Figure 5.6 Gke Cluster Security. Image. Binary authorization, from my experience, was heavily tested, and therefore I would advise you to memorize the terms such as attestation and attestation, as well as what container analysis is. Container analysis and binary authorization could be confusing on the exam. Test tip: container analysis is an API that must be enabled during the binary authorization process. When automating your CI/CD processes, you will execute the standard tasks of building your app. Test your app. Containerize it. Deploying it to Google Cloud Repositories. Create an image digest from the image. Sign it with the private key from a PGP key pair. Create an attestation. Finally, deploy it to binary authorization. IAM policies per environment. Cloud Identity and Access Management, IAM, provides more granular access to specific Google Cloud resources and prevents unwanted access to other resources. IAM lets you control who, users, have what access, roles, to which resources by setting IAM policies. A policy is a collection of bindings, audit configs and metadata which binds one or more members to a single role. Members can use user accounts, service accounts, Google Groups, and XUI domains. The role is a named list of permissions. Each role can be an IAM predefined role or a user-created custom role. Test tip: the role binding in a Cloud IAM policy is the combination of both the role and the list of members. Cloud IAM policies can be written in JSON or YAML. Note that the policy manages access to the resource itself as well as any child resources through policy inheritance. Section 3, Exam Guide. Implementing Service Monitoring Strategies. Exam Objectives. Note icon image. Let's discuss the exam objectives. Topic: Exam Objective Coverage for SRE-related objectives in Section 1 of the Exam Guide. In this topic, we cover the exam objectives in order with concise detail. Exam Objectives. Implementing Service Monitoring Strategies. Exam Guide. Section 3, Implementing Service Monitoring Strategies. 3.1 Manage Application Logs. Collecting logs from Compute Engine and Gke using Stackdriver logging and Fluent. Stackdriver logging agents stream logs from your VM instances and from selected third-party software packages to cloud logging. For advanced metrics, You would need to install Stackdriver logging agent. Installing the agent was covered in the chapter Stackdriver. Test tip: VMs running on Google Kubernetes Engine or App Engine have the agent is already included in the VM image. It is best practice to run the logging agent on all your VM instances. After installing, the agent credentials may need to be configured if the default service account was not used. Collect third-party unstructured logs using Stackdriver logging and Fluent, sending application logs directly to Stackdriver API using Stackdriver logging. 3.2 Manage application metrics with Stackdriver monitoring. Collecting metrics from Compute Engine. What makes Stackdriver monitoring with Compute Engine instances so easy is that it will automatically collect and report many basic metrics to Stackdriver monitoring, such as instance unknown caller, uptime, CPU utilization, and memory utilization. However, there are advanced metrics that require an agent to provide more detailed CPU, memory, and disk metrics. Custom monitoring metrics are metrics that you write and use like any other metric in Stackdriver, including for alerting and dashboards. You can use Cloud Scheduler to send a Cloud Pub submessage, which then triggers the first Cloud function to gather a list of projects via the process of collecting instance counts every 10 minutes. To find the number of VMS in a project, you can get a list of VMS using Projects List with Cloud Resource Manager API. The Use the Compute Engine API Instances List method. Write list to Stackdriver monitoring is a custom metric. Build a dashboard to ease the view. Collect Gke Kubernetes metrics. Kubernetes Engine Operations is designed to monitor Gke clusters. It manages monitoring and logging services together and features a Kubernetes Engine Operations dashboard that provides a customized interface for Gke clusters. When creating the cluster initially, you can enable telemetry in two approaches. At the time of writing, Kubernetes Engine Operations is the default option, starting with a Gke version 1.14. However, legacy logging and monitoring is still available and allows you to disable cloud logging while still using cloud monitoring. See figure below. Test tip: Kubernetes Engine monitoring increases observability by aggregating instance, system metrics, and logs into a single view. Important note: Kubernetes dashboard add-ons are now deprecated. You can use the Cloud Console to manage and monitor your Kubernetes clusters, workloads, and applications. Figure 5.7 shows the telemetry options for Gke monitoring. Figure 5.7 Gke telemetry. Image. There are other options as well for monitoring. For example, Prometheus is a monitoring tool often used with Kubernetes. Test tip: Prometheus can be used and is a monitoring tool often used with Kubernetes if you do not use legacy logging and monitoring. If you configure Kubernetes Engine Operations and include Prometheus support, then metrics that are generated by services using the Prometheus exposition format can be exported from the cluster and made visible as external metrics in cloud monitoring. You do need to install a collector and assign the Kubernetes Engine cluster admin role to the cluster. For more on this capability, view the site on Google Cloud. https://cloud.google.com/stackdriver/docs/Kubernetes-engine/Prometheus link. Use Metric Explorer for ad hoc metric analysis. Metrics Explorer lets you build charts for any metrics collected by your project. It is available on the Stackdriver monitoring dashboard. Figure 5.7 shows the Metrics Explorer with various resource options in the drop-down menu. Figure 5.7 Metrics Explorer. Image. With Stackdriver monitoring Metrics Explorer, you can rapidly build a query by selecting resources and metrics. After selecting the resources and the metrics, you can save to the dashboard. For example, you can then drill into the dashboard and view the metrics, status, and performance of your cluster in Gke. Figure 5.8 shows the Gke cluster status from the Stackdriver dashboard. Figure 5.8 Gke cluster status. Image. 3.3 Manage Stackdriver monitoring platform. Creating a monitoring dashboard. Dashboards are created from the Stackdriver console. Figure 5.9 shows the dashboards under Stackdriver monitoring. Figure 5.9 Dashboards. Image. When you select Create Dashboard, you will be prompted for the name. Figure 5.10 shows the dialog box for creating a new Stackdriver dashboard. Figure 5.10 New dashboard name. Image. Figure 5.11 shows the new Stackdriver dashboard without charts. Figure 5.11 Empty dashboard. Image. Figure 5.12 shows the new Stackdriver dashboard. Add chart options for Kubernetes cluster. Figure 5.12 Kubernetes cluster chart creation. Image. Figure 5.13 shows the new Stackdriver dashboard workloads showing CPU utilization, memory and incidence. Figure 5.13 Kubernetes cluster workloads. Image. Filtering and sharing dashboards. Dashboards can only be viewed and filtered under the dashboards console to view specific ones and remove monitoring noise. Figure 5.14 shows filter dashboards before filtering. Figure 5.14 dashboard filtering. Image. Configure third-party alerts in Stackdriver monitoring. Third-party alerts can be enabled under the alerting menu and by selecting Add Notification Channel. When alerting policy violations occur, you will be notified via the channel selected. You can also add a notification channel from the Cloud Command tool. Cloud Beta monitoring channels. Create channel content from file equals pub sub channel JSON. Figure 5.15 shows add notification channel. Figure 5.15 notification channel. Image. Design Stackdriver Workspace strategy. Workspace can manage the monitoring data for a single Google Cloud project, or it can manage the data for multiple Google Cloud projects and ORS accounts. When designing a strategy, you might want to create a separate workspace for different teams or development groups. It is also possible to merge workspaces or move them into other projects. 3.4 Manage Stackdriver Logging Platform. Enabling data access logs. Cloud Audit Logs is a service that consists of 2 log streams and does need to be enabled. Admin Activity Data Access, GCP Services. You can enable these logs under Logging settings. These streams help you answer the question of who did what, where, and when within your GCP projects. Enabling VPC Flow Logs. VPC Flow Logs have been tested and we need to know a few things for the exam: how to enable, why we use flow logs, how to review them, how to enable flow logs. When you enable VPC Flow Logs, you enable all VMs in a subnet, and to enable, select Enable by turning flow logs under subnet. Figure 5.16 shows how to turn on flow logs under VPC settings. Figure 5.16 Flow Logs enablement. Image. Why use VPC Flow Logs? VPC Flow Logs records a sample of network flows sent from and received by VM instances and instances used as Kubernetes nodes, GKE. These VPC Flow Logs can be used for network monitoring, forensics, real-time security analysis, and expense optimization. You can view flow logs in logging, and you can export logs to any destination that is supported. Supported destinations for exported log entries are cloud storage, BigQuery, and PubSub. Flow logs are aggregated by connection from Compute Engine VMs and exported in real time. Test tip: by subscribing to Cloud PubSub, you can analyze flow logs using real-time streaming APIs. You may want to review this GCP page: https://cloud.google.com/vpc/docs/using-flow-logs link. Viewing logs in GCP console. We can view activity logs in your console as well as Stackdriver logs. Activity logs can be viewed in the Cloud console by selecting the Activity section in the console. You can also filter for users as well as activity types, which are configuration, data access, development, and monitoring. Figure 5.17 shows the activity logs in the console. Figure 5.17 Activity Logs. Image. In the figures above we have configuration activity, where everything from VMs being created to writing Kubernetes entities. Logs Viewer is integrated into Stackdriver Logging and can be accessed by going to Stackdriver Logging, Logs Viewer. Logs Viewer allows you to filter logs based on resources, logging levels, time and more. In this dashboard you can also create metrics, create syncs and save searches. There is also an arrow icon which you can select for streaming logs, which can help in identifying resource issues when they happen. Figure 5.18 shows the activity logs in the console for GKE streaming. Figure 5.18 Streaming Activity Logs. Image. Using basic versus advanced logging filters, there are 2 specific methods in the Logs Viewer to view logs: basic and advanced. Basic is used for easy viewing and when you do not need to perform label or text searches. Test tip: by filtering log files, you may want to obtain more granularity by using a Boolean search. Advanced filtering, which uses a Boolean expression that specifies a subset of all the log entries in your project. Below is an example of the Boolean search. Figure 5.19 shows the advanced filtering capability while logging. Figure 5.19 Boolean search image. Use advanced logging T can be used to do any of the following. Choose log entries from specific logs or log services. Choose log entries within the time range. Choose log entries that satisfy conditions in metadata or user-defined fields. Choose a sampling percentage of all log entries. There is a specific syntax structure that is used, and you can find out more here. https://cloud.google.com/logging/docs/view/advanced queries implementing logs-based metrics. Based metrics are cloud monitoring metrics that are based on the content of log entries. Metrics can record the number of log entries containing particular messages, or they can extract latency information reported in log entries. There are two types: system, logs-based, metrics are predefined by logging, user-defined. Logs-based, metrics are created by a user on a project. The data for logs-based metrics comes from log entries received after the metrics are created. Figure 5.20 shows the logging-based metrics with metric samples. Figure 5.20 Logging-based metrics. Image. To get to log-based metrics, simply go to Logging, Log-based metrics. Understanding the logging exclusion versus logging export. The logs viewer gives you tools to disable all log ingestions or exclude, discard log entries you're not interested in to minimize your costs. Figure 5.21 shows the logging ingestion dashboard with current statistics. Figure 5.21 Logging ingestion. Image. There are two kinds of exclusions. Exclusion queries give you the flexibility to select log entries for exclusion based on query expressions. You can use exclusion queries to choose a random sample of log entries to exclude resource type. Exclusions allow you to block all logs from specific resource types. Logging considers both kinds of exclusions when deciding whether or not to exclude a log entry. If any resource type exclusion or any exclusion query matches the log entry, then that log entry is excluded. Select the option for logging export. Supported destinations for exported log entries are cloud storage, BigQuery, and PubSub. You can export log entries using the Cloud Console, Cloud Logging API, or the Cloud Logging command line tool. View export logs in Cloud Storage and BigQuery to view logs in BigQuery. Go to the BigQuery UI in the Cloud Console. Go to BigQuery. Select the dataset used as your sinks destination to view logs in Cloud Storage. Go to Cloud Storage Browser in the Cloud Console. Go to Cloud Storage Browser. Select the bucket you are using for logs export. Select one of the dataset tables. Log entries are visible on the Details tab, or you can query the table to return your data. Section 4, Exam Guide, Optimizing Service. Performance Exam Objectives. Note icon image. Let's discuss the exam objectives topic. Exam objective coverage. For performance in this topic we cover the exam objectives in order with concise detail. Exam objectives. Optimizing service performance. In this topic, we cover the exam objectives in order with concise detail. Exam objectives. Building and implementing CI/CD pipelines for a service. 4.1 Identify service performance issues. Utilize Stackdriver to identify cloud resource utilization. Stackdriver provides visibility into the performance, uptime, and overall health of cloud-powered applications. Stackdriver collects metrics, events, and metadata from Google Cloud as well as Azure to provide deep insight into your cloud components. Stackdriver ingests that data and generates insights via dashboards, charts, and alerts. Utilize Stackdriver Trace Profiler to profile performance characteristics. Interpret service mesh telemetry. Troubleshooting issues with the Image OS. Troubleshoot network issues. 4.2 Debug application code. Figure 5.21 shows the trace on a URI being ranked. Figure 5.21 Trace. Image. Figure 5.22 shows the overview of a trace. Figure 5.22 Stackdriver Trace. Image. Debugging distributed applications. App Engine Local Development Server. Stackdriver Error Reporting. Stackdriver Profiler. 4.3 Optimize resource utilization. Identify resource costs, whether current or forecasted, can be viewed efficiently in the Cloud Billing Dashboard. Figure 5.23 shows the billing console with current statistics. Figure 5.23 Billing Console. Image. Pricing is also under billing. The SKUs and prices are for Google Cloud Platform services, Google Maps platform, and G Suite per pricing SKUs that are tied to your account. Figure 5.21 shows the pricing SKUs that are available on your account. Figure 5.24 billing pricing SKUs. Image. Cloud Pricing Calculator. We have an online pricing calculator that can provide an estimate of costs for your cloud resources. It is intuitive to use and has been covered in previous sections. https://cloud.google.com/products/calculator. Link. Note: several components of Google Cloud Platform, including Cloud Deployment Manager, Cloud SDK, Cloud Resource Manager API, and the Cloud Calculator, are all provided free of charge. Cloud Pricing page has pricing information for each service. https://cloud.google.com/pricing. link. Recommendation Engine. Compute Engine provides machine type recommendations to help you optimize the resource utilization of your virtual machine instances. Test tip: these recommendations are generated automatically based on system metrics gathered by the Google Stackdriver monitoring service over the previous 8 days. This feature is also known as right-sizing recommendations. Figure 5.24 shows the recommendation engine providing a recommendation in the Compute Engine dashboard. Figure 5.24 Recommendation Engine. Image. Identify resource utilization levels. Budgets and alerts can be set up in the pricing console. Budgets track expenses within a Google Cloud Platform project or billing account. Your budget can be a specified amount or based on your previous spend. You can set alerts to notify billing admins and users when a budget goes over a specified amount. Figure 5.25 shows the budget and alerts under billing. Figure 5.25 Budgets and alerts. Image. When you set up a budget, you can get alerted to email. For example, the alert will be set to be triggered after a threshold has been set. Test tip: budgets can be set up for the scope of the project or even individual services. Figure 5.26 shows the budget scope under the billing dashboard. Figure 5.26 Budget scope. Image. The figure below shows an alert threshold that will trigger when $100, $180 and $200 thresholds have been reached. These alerts should prevent surprises in cloud spending. Figure 5.27 shows the budget alerts thresholds for sending alerts when a threshold is reached. Figure 5.27 Alerts thresholds. Image. You can also go to billing and view the current cloud spend. Figure 5.28 shows the billing report for May 2020. Figure 5.28 Billing report. Image. Billing reports are also a great way to explore the granular cost details of your cloud spending. You can also share reports as well as export reports. Test tip: billing reports can be exported to BigQuery or cloud storage. Figure 5.29 shows billing reports with current spend and a forecasted spending. Figure 5.29 Billing reports. Image. Develop a plan to optimize areas of greatest cost or lowest utilization. One of the challenges around the cloud is not around technical concerns but more around financial concerns. We need to have full visibility around costs and be able to identify who is using what resources. Cloud spending is an ever-increasing challenge, especially when resources are ever more complex and data storage requirements grow exponentially every year. We have excellent resources in Google Cloud such as Cloud Billing, Resource Manager, Stackdriver monitoring and other tools services. Google has an excellent post on this. Please see the link below. https://cloud.google.com/blog/topics/cost-management/principles-of-cloud-cost-optimization. Manage preemptible VMs. Preemptible VMS is a great way to run a very short-term batch job. For example, a preemptible VM is an instance that you can create and use at a discounted price. They last no longer than 24 hours and can be terminated, preempted, if Google requires access to those resources for other tasks. Google Compute Engine will initiate a preemption notice for the instance in the form of an ACPIG2 soft off signal. If a graceful shutdown is important, then you should use a shutdown script to handle the preemption notice and complete cleanup actions before the instance stops. Figure 5.30 shows the preemptibility options in Compute Engine. Figure 5.30 Preemptibility. Image. Work with committed use discounts. A committed use discount is similar, for example, in ORS to what is called a reserved instance in GCP. when working on a long-term project or even a use case for infrastructure deployment workloads. You can purchase commitments to get a heavy discount. You will select either 1 or 3 years for usage of CPUs and memory. Figure 5.31 shows the comparison options from OR's compute engine. Figure 5.31 comparing OR's and GCP compute billing. Image. Consider network pricing. The cloud is all about networking when it comes to accessing resources. We need to use networking, and these services will run charges when developing applications. For example, understand that every API call the application makes could result in a cost to the company's cloud spending. Most access to resources is done through APIs which access the cloud resources for the application users. There are 2 types of network access that can incur usage charges, which are ingress-egress. Ingress means that you are placing, modifying, or viewing resources. APIs use certain calls to accomplish, some of which are GET, PUT. For example, sending traffic between virtual machines through external IP addresses will incur costs. Network logs generate charges. Charges incurred for the following products: VPC Flow Logs, firewall rules logging, cloud NAT logging. To understand more details for network charges with Google Cloud, please refer to the following link: https://cloud.google.com/compute/network-pricing link. We have an online pricing calculator that can provide an estimate of costs for your network transfers. This calculator has several options to review for network-related pricing: networking, egress, interconnect with cloud VPN, cloud load balancing, cloud endpoints. Figure 5.32 shows the pricing calculator with an estimate for egress. Figure 5.32 pricing calculator. Image. Note: several components of Google Cloud Platform, including Cloud Deployment Manager, Cloud SDK, Cloud Resource Manager API, and the Cloud Calculator, are all provided free of charge. Section 5, Exam Guide, Managing Service Incidents. 5.1 Coordinate roles and implement communication channels during a service incident. When Google declares an incident, they designate an incident commander who coordinates incident response and resolution. The incident commander selects specialists from different teams and forms a response team. Google believes in having subject matter experts who are deployed to respond to any type or size of data incidents. Define roles in service incidents. The incident commander is the lead that is responsible for the response and closure of any incidents. They delegate responsibility and ensure proper communications or facilitate. The incident commander's most important responsibility is to maintain a living incident document, such as through Slack, Wiki, etc. The communications lead will handle the messaging to the stakeholders. Operations lead is a technical leader that will handle direct responses from an investigative and closure perspective. Subject matter experts are specialists in specific subject areas such as compliance or support. Handle requests for impact assessment. During the course of managing an incident, an impact assessment is a key aspect of responsible requirements management. Teams need to regularly talk with each other about business and production priorities. The SRE and developer leadership teams should ideally work as a unit, meeting regularly and exchanging views about technical and prioritization challenges. Requests for impact assessments should be considered when prioritizing a request and is whether a joint engagement might help reduce the backlog. Provide regular status updates, internal and external. Updates on the status should be provided by the incident commander and should be provided through the incident response channel IC. The incident commander also maintains the live incident state document, which is a living document. There is an example of this document: https://landing.google.com/sre/book/chapters/incident-document. /link record major changes in incident state. Updating the live incident state document is critical whenever there is a change of state. A change of state meaning the incident has been officially declared, the outage has been cleared, or even a level of service may have been affected. For example, perhaps the outage is not visible to the customer but it's visible to the SRE team. Do you declare an incident? Your organization may want to have set up very clear classifications for alerts such as L1, L2, etc. Establish communications channels. Communications between team members should be clear and open. You may want to use Slack, Google Hangouts, Skype, or even Zoom. Create a designated email alias with members added to the list. Have a clearly documented channel that can be recorded and even auditable for future reference. Scaling response team and delegation. Incidents may require additional resources, and those resources may need to come from other departments if the workload on a given member becomes excessive. That person needs to ask the planning lead for more SRE members. Several distinct roles should be delegated to particular individuals as needed. SMEs may need to be leaders in database problems. The incident commander, IC, holds high-level status around the incident and is responsible for delegating additional staff. Avoid exhaustion. Burnout exhaustion may manifest as showing signs of physical, mental and/or emotional exhaustion as a result of stress related to their job or workplace. SRE teams have specific constraints on the quantity and quality of on-call shifts. SRE managers are responsible for keeping their on-call workloads balanced and sustainable. Vacations, job rotations and other forms of compensation should be considered. Rotate handover roles. Jobs do rotate just like people rotate through jobs. We need to ensure our SRE members are in roles long enough to perform well, but then we should consider rotation between SRE and development or even production roles. Being an SRE is demanding, so rotation is a great way to minimize long-term burnouts and exhaustion. Manage stakeholder relationships. Stakeholders are the users or the application owners who generally are going to be concerned their applications are either performing poorly or not at all. Set reasonable expectations of when the service should be back to normal and also communicate promptly. And F5.2 investigate incident symptoms impacting users with Stackdriver RIME. Identify probable causes of service failure. Services fail for many reasons and it's important to identify. However, the priority is to get the service back online before performing root cause analysis. Perform an investigation to isolate the most likely actual cause. A root cause needs to be identified, at which point we can then take corrective action to prevent a recurrence and write a post-mortem. Reviewing Stackdriver logs files can be a good start, and reviewing VPC logs as well for any issues. Of course, fixing the proximate cause, needn't always wait for root causing or post-mortem writing. Identify alternatives to mitigate issues. Sometimes fixing the real root cause may not be that easy. Impacts can be minimized by several methods. Mitigation could be anything from increasing the configuration resources, adding load balancing or auto-scaling. 5.3 Resolve issues. Verify fix. Once your team has troubleshooted the issue and resolved the issue, there should be a documented fix. Reliability is a function of mean time to failure, MTTF, and means time to repair. Declare the all clear. When your team is resolving issues and you're confident the problem has been resolved, declaring an all clear is acceptable. When declaring this all clear to ensure that the incident has been fully resolved, this all clear should be documented as well as to how this all clear was validated in the post-mortem. Post an update on the communication channel as well to ensure the stakeholders are fully aware. Lastly, after the all clear has been confirmed by the system being brought online, then you would want to proceed with determining the root cause. 5.5 Document issued in a post-mortem. Document root causes. It is very important to write up a post-mortem document so as to ensure that the incident is clearly documented for further reference. This plays into the lessons learned for future SREs and can also aid as a valuable learning tool. Documenting the root cause of the post-mortem is very important to ensure that preventive actions are put in place. An SRE must clearly communicate the root cause to the stakeholders and their team members. A post-mortem is necessary. Create and prioritize action items. When creating and prioritizing actions, it is required to identify, for example, how to prevent the outage from occurring again. Identify the root cause and specify tracking metrics so that action items are followed up on. With the action item should be an owner, remediation, plan to remediate, and other information to ensure that the action item is very clear. For example, we do not want to state that the remedy to the failure is to mitigate, remove, improve, but instead be very clear, such as remove line of code 37 in a program script located in directory myshare for the MyPuzzle application. Lastly, it would also be imperative to identify how to validate if the action item has fixed the issue. Communicate post-mortem to stakeholders. When communicating the root cause via post-mortem report, ensure they are blameless post. Mortems are an important tenet of SRE culture. Google believes in constructive post-mortems that are blameless and are not pointing fingers. There you have the full coverage of the official objectives. Completion of content. Congratulations on completing the objectives of the book. Proceed on to the mock exams and test your knowledge before taking the exam. Review the questions that are not clear to you. Lastly, please review the terminology in the appendix as well. Appendix A, GCP DevOps Engineer Practice Mock Exams Chapter Introduction. Before you begin, the main objective of these mock exams is to validate that you have learned the objectives of this chapter. Answers with explanations are on the following pages. If you do well on these exams, over 75%, you should feel confident to sit for and pass the DevOps exam immediately. Additional free practice questions are available online at https://techcommanders.net/GCP free practice link. GCP DevOps Practice Exam 150 questions. This practice exam is followed with the same practice exam with answers and explanations. 1. You have downloaded the SDK kit from Google and now would like to manage containers on Gke with Cloud. What command should be typed to install Kubectl in the CLI? Cloud Components install Kubectl. Cloud Components Kubectl install. Cloud Components install Kubernetes. Cloud Components install Components Kubectl 2. A recent software update to your enterprise e-commerce website that is running on Google Cloud has caused the website to crash for several hours. Your CTO has decided that all critical changes must now have a backout rollback plan. The website is deployed on hundreds of virtual machines, VMs, and critical changes are frequent. What 2 actions should you take to implement the backout rollback plan? Use managed instance groups with the update instances command when starting a rolling update. Enable object versioning on the website's static data files stored in Google Cloud Storage. Create a new instance template with applied fixes and roll out via A/B test. Use unmanaged instance groups with the update instances command when starting a rolling update. 3. Your company uses a third-party monitoring solution for your enterprise apps. You are using Kubernetes Engine for your container deployments and would like to enable this internal monitoring app for Kubernetes clusters. What would be the best approach? Select 1. Deploy the monitoring pod as a daemon set. Deploy the monitoring pod as a cluster. Deploy the monitoring extension for Stackdriver. Trace. Deploy a solution from the cloud marketplace for as the monitoring agent, is based on the original collected system statistics collection daemon. Select 1. Stackdriver. Agent. Stackdriver. Agent. Collected Stackdriver. Collected Stackdriver. Stats. 5. You are currently deploying an application on a Kubernetes cluster. You're aware that a deployment rollout is triggered if and only if the deployment's pod template is changed. For example, if the labels or container images of the template are updated. Other updates, such as scaling the deployment zone, do not trigger a rollout. What is the file name that would need to be changed? Select 1. .spec template YAML app.py .template YAML .spec template 6. Which of the following is the maximum size of a single cache data value in memcache? Select 1. 10 megabytes, 1 megabyte, 1 gigabyte, 10 gigabytes. 7. Your containers are currently running on Google Kubernetes Engine. You have decided to also monitor the nodes that Gke has deployed on your containers on. You have set up logging information from your application to be sent to Stout while your app begins as a system service on your Gke. Without changing the app, how do you get logs sent to Stackdriver? Select 1. Install Stackdriver logging agent. Review the application logs from the Compute Engine VM instance. syslog logs in Stackdriver. Review the application logs from the Compute Engine VM instance. activity logs in Stackdriver. Delete the application logs from the Compute Engine VM instance. activity log in Stackdriver. Install Stackdriver logging agent. Review the application logs from the Compute Engine VM instance. System event logs in Stackdriver. 8. You're considering placing your infrastructure as code process on Cloud Deployment Manager. What would be the risk of doing this? Select 1. Cloud Deployment Manager requires a Google APIs service account to run. Cloud Deployment Manager APIs could be deprecated in the future. Cloud Deployment Manager can be used to permanently delete cloud resources. Cloud Deployment Manager takes some training to use. 9. Does App Engine have several solid use cases? What are the 3 use cases that would be specified? Select 3. Develop applications on a hosted platform. Testing applications on a hosted platform. Deploy your VDI application on a hosted platform. Scaling applications on a hosted platform. Deploy your SaaS application on a hosted platform. 10. You're using Stackdriver to set up alerts. You may want to reuse your existing REST-based notification tool that your ops team has created. You also need the setup to be as simple as possible to configure and maintain since your customer does not have programming skills. Which notification option would be the best option? Select 1. Send notifications via SMS and use a custom map to forward them to the REST API. Create a webhook to get this done. Send it to an email account that is being polled by a custom process that can handle notifications. Send notifications via Cloud Pub Sub and use a custom map to forward them to the REST API. 11. You would like to create a new repository in Cloud Source Repositories with Cloud. What would be the command to create a repo called Devops? Home. Second, no. Select 1. Cloud Source Repo create Devops Cloud Source Repos create Devops Cloud create Source Repos Devops Cloud create Source Repos Devops. 12. You're currently ready to deploy some Cloud Deployment Manager templates and you will need to ensure specific requirements explicit exists before the templates deploy. What would be the option you would like to add to your templates or configuration files? Select 1. Depends on properties variables deploy. On 13. What would be the best definition of stateful sets with Google Kubernetes Engine? Select 1. Stateful sets represent a set of pods with unique, persistent identities and stable host names that Gke maintains regardless of where they are scheduled. Stateful sets represent a cluster with unique, persistent identities and stable host names that Gke maintains regardless of where they are scheduled. Stateful sets represent a service with unique, persistent identities and stable host names that Gke maintains regardless of where they are scheduled. Stateful sets are applications which do not store data or application state to the cluster or to persistent storage. 14. You are currently working on a pipeline that is hosted on GCP and you are getting ready to deploy your working copies with Cloud Build. The following command would do what as part of the process: git check out a new feature. Select 1. Create a development branch and push it to the Cloud Build server. Create a development branch and push it to the Git server. Create a production branch and push it to Kubernetes. Create a production branch and push it to the Git server. 15. Your company is getting ready to deploy a CI pipeline to GCP. You need to confirm that you have the proper syntax for creating a Kubernetes namespace called production that will logically isolate the deployment. What is the Kubernetes command to do this? Select 1. Kubectl namespace creates production. Kubectl creates namespace production. Kubectl create ns production. Kubectl ns create production. 16. We would like to add strict deploy time policy enforcement to your Kubernetes engine cluster. What would be your best option? Select 1. Binary authorization IAM policies shielded VMS Cloud Armor Security Scanner. 17. Your CISO has advised that you will need to maintain a record of all policy violations and failed deployment attempts around your Gke container deployments. What services in Google Cloud would be the best solution? Select 1. Binary authorization container analysis. Use a cloud marketplace solution for Gke logs. Cloud audit logs. Use a cloud marketplace solution for Splunk. 18. Which of the following is an API that is used to store trusted metadata about our software artifacts and is also used during the binary authorization process? Select 1. Attestation container analysis. DLP Cloud Audit. 19. Where does container analysis store resulting metadata and make it available for consumption through an API? Select 1. Container Registry. Source Repositories. Cloud Storage. Gke persistent storage. 20. Container analysis performs vulnerability scans on images in Container Registry and monitors the vulnerability information to keep it up to date. What are the two main tasks that container analysis performs? Select 2. Incremental scanning, vulnerability reporting, continuous analysis, continuous logging. 21. We are designing a CD pipeline and would like to have your source code hosted on Gke. Build automation and artifact management with GCP services. You're currently using Spinnaker for your code deployment. Refer to the diagram and place it in the proper sequence for A, B, C to design your initial CD pipeline. Select 1. Cloud Source Repositories. Cloud Build. Gke Cloud Build. Cloud Source Repositories. Container Registry. Cloud Source Repositories. Cloud Build. Container Registry. Kubernetes Engine. Cloud Source Repositories. Container Registry. 22. What would be the reason for implementing Cloud Run APIs? Select 1. Deploy and manage user-provided container images that scale automatically based on HTTP traffic. Deploy and manage user-provided virtual machine images that scale automatically based on HTTP traffic. Deploy and manage user-provided container Images that scale automatically based on TCP UDP traffic. Deploy and manage applications that provide container images that scale automatically based on HTTP traffic. 23. You have just created a cluster called Devops in Gke, and now you need to get authentication credentials to interact with the cluster. What is the proper CLI syntax to accomplish this task? Select 1. Cloud Containers Cluster Get Credentials Devops Cloud Container Clusters Get Credentials Devops Gke Container Clusters Get Credentials Devops Gke Containers Cluster Get Credentials Devops. 24. Your cluster has just started and deployed your pods. You now need to view all the running pods. What is the proper CLI syntax to accomplish this task? Select 1. Gke Get Pods. Gke List of Pods Cloud Get Pods Cloud List Pods. 25. You have been contacted by the enterprise support team, which has told you there have been reports of significant latency at specific times for an application running on GCP. They would like you to review the issue and provide them insight into why the application is latent at specific times. What Google Cloud Service could you use to inspect latency data that has been collected in near real time? Select 1. Stackdriver Debug Stackdriver Trace VPC Trace Logs. Stackdriver Profiler. 26. What is the main issue that SRE really exists to solve? Select 1. Reduce latency of applications. Increasing the performance of applications. Remove silos from the organization and create a hybrid role. Remove layers of redundancy in software development. 27. Which of the following statements is true when discussing toil in SRE? Select 2. Reducing toil is one of the most important tasks of an SRE. A toil budget is a result of toil hours minus toil costs. Toil is mundane, repetitive operational work providing no enduring value, which scales linearly with service growth. Reducing toil is not expected as an SRE. It is DevOps that reduces toil. 28. Which of the following are the typical SRE activities according to Google? Select 1. Software engineering, systems engineering, toil and overhead. Software engineering, systems development, toil and overhead. Software architecture, systems engineering, toil and overhead. Software engineering, systems engineering, toil and support. 29. Which of the following statements is true around simplicity around software systems? Select 2. Simple releases are generally better than complicated releases. Constantly strive to eliminate complexity in the systems they onboard and for which they assume operational responsibility. Expected and accepted complexity will be introduced into the systems for which they are responsible. Reliability is the main prerequisite over simplicity. 30. Which of the following is not possible to use primitive roles in GCP? Select 1. Allows a user access to view all datasets in a project, but does not run queries on them. Allows development owner access and production editor access for all datasets in a project. Allows a user access to view all datasets in a project. Only none of the above. 31. You're currently an SRE for My Widgets Corporation. The development team has asked you to deploy a Java 9 application on GCP App Engine. You realized that you can't use App Engine Standard because Java 8/11 is the only Java version supported at the time of your planning. What are your options for this scenario? Select 2. Advise the team to know that the App Engine Standard does not support this runtime environment. App Engine Flexible will work with custom runtimes on containers. I'll let the team know that they will deploy this internally. Pasha Abdul. It's not support on GCP. App Engine Flexible will deploy VMs only. 32. You're currently considering moving your on-premises CI pipeline from on-premises to Google Cloud Platform. You would like to have the code maintained in a private Git repository which is hosted on the Google Cloud Platform. What service would you choose? Select 1. Container Registry Kubernetes Engine Cloud Source Repositories Cloud Build Cloud Run. 33. Google Cloud has both. Pasha Abdul. Types of services that are ops and no-ops management requirements when it's referring to customizability with compute services. How would you rank the 4 computed services on a scale ranging from the fewest management requirements and lowest customizability to the highest management requirements and highest customizability? Select 1. Cloud Functions, Compute Engine, Kubernetes Engine, App Engine Cloud Functions, Kubernetes Engine, App Engine Compute Engine Cloud Functions, App Engine, Kubernetes Engine, Compute Engine Cloud Functions, App Engine, Compute Engine. Kubernetes Engine 34. You have been contacted by your CIO to improve your application availability. You have decided to use instance groups by spreading your instances across 3 zones. What type of instance group are you selecting? Select 1. Multi-regional managed groups, multi-zonal managed groups, regional managed groups, personal managed groups. 35. Google states that an SRE should spend no more than what percentage of time on operations? Select 1. 75%, 50%, 100%. There is no number to follow none of the above. 35. Google states that an SRE should spend no more than what percentage of time on operations? Select 1. 75%, 50%. 100%. There is no number to follow none of the above. 36. You have created a new image of an application without the signature part and you tried to deploy it. Instead of deploying, you received an error denied by a tester. What could be the problem to resolve? Select 1. Create an attestation and submit to binary authorization. Enable cloud build with proper permissions. In IAM, the app was deployed via marketplace solution that expired and needs to be renewed. Extract the signature of PGP with PuTTY. 37. Who in an SRE organization coordinates the efforts of the response team to address an active incident? Select 1. Primary Engineer Incident Commander Communications-led Project Manager. 38. What role in an SRE organization manages the immediate, detailed, technical, and tactical work of the incident response, which is typically the largest aspect of the response? Select 1. Operations-led Incident Commander Communications-led Project Manager. 39. You are helping with the design of an e-commerce application. The web application receives web requests and stores sales transactions in a database. You need to identify minimal service level indicators, SLEs, for the application to ensure that forecasted numbers are based on the latest sales numbers. Which SLEs should you set for the application? Select 2. Web application, availability. Web application, durability database, availability database. Freshness. 40. Your site reliability engineering team routinely performs toil work to archive unused data in tables within your application's relational database. This tool is required to ensure that your application has a low latency service level indicator, SLE, to meet your service level objective, SLO. Toil is preventing your team from focusing on a high priority engineering project that will improve the availability of SLE in your application. If you want to reduce repetitive tasks to avoid burnout, improve organizational efficiency, and follow the site reliability engineering recommended practices, what should you do? Select 1. Change the SLO to meet the SLA. Change SLE availability to meet the SLA. Identify repetitive tasks that create toil and automate as much as possible. Contact your staffing company for help. 41. Your application runs in Google Kubernetes Engine, GKE. You may want to use Spinnaker with Kubernetes Provider v2 to perform blue-green deployments and control which version of the application receives traffic. What should you do? Select 1. Use the Kubernetes replica set and then use Spinnaker to create a new service for each new version deployed. Use a Kubernetes deployment and use Spinnaker for each new version of the application. Use the Kubernetes replica set and then use Spinnaker to update the replica set for each new version deployed. Use a Kubernetes deployment objective and use Spinnaker for each new version of the application. 42. You are deploying an application to a Kubernetes cluster that requires a username and password to connect to another service. When you deploy the application, you want to ensure that the credentials are used securely in multiple environments with minimal code changes. What should you do? Select 1. Use a Kubernetes secret and set up a KSM to handle the secrets. Store your credentials in a Kubernetes secret and then allow the application access via environmental variables at runtime. Bundle the secret into a file on your desktop and add as needed. Enable the Kubernetes secret API and then set up a KSM to handle the secrets. 43. You need to create many projects for many different teams. You may want to use a Cloud Deployment Manager, DM, deployment to create these projects in a folder called Devops 1. What should you do? Select 1. This cannot be done. Use Terraform since it supports teams better. Create a project called Devops 1 and enable appropriate APIs. Grant the project create a role to the service account. Use command Cloud Deployment Manager deployments. Create project Devops 1. Create a project called Devops 1 and enable appropriate APIs. Grant the project owner's role to the service account. Use command Cloud Deployment Manager deployment. Create project Devops 1. Create a project called Devops 1 and enable appropriate APIs. Grant the organization's role to the service account. Use command Cloud Deployment Manager deployments. Create new project Devops 144, which command will configure Cloud Build to store the image in container registry as part of the build flow. Select 1. Push command Docker push command. Docker push command pull command 45. What is the maximum size of a log entry by logging in? Select 1. 128, 256, 512, 127. 46. What does cloud logging in Google Cloud include as part of the service? Select 3. User interface, logs viewer, API for programmatic access, storage for logs, analytics tools, Kubernetes logging extensions. 47. What is the default retention period for admin activity logs? Select 1. 30 days. 400 days, 500 days, 31 days. 48. Which of the following two statements is true about Stackdriver logging with Kubernetes engine? Select 2. Stackdriver is the default logging solution for clusters deployed on Google Kubernetes engine. To ingest logs, you must deploy the Stackdriver logging agent to each node in your cluster. The actual deployment of config map and daemon set for your cluster depends on your node licenses. Stackdriver logging is deployed to a new cluster by default and you cannot opt out. 49. Which role does your service account for Gke need to be granted to access cloud storage and perform a storage buckets update? Select 1. Project owner storage admin storage object viewer project creator. 50. Cloud Trace can collect latency data from which of the following services? Select 1. App Engine Gke load balancers applications, all the above. GCP DevOps Engineer Practice Exam 150 questions. Pasha Abdul.